Now, from one of the longest videos to one of the shortest. Single line drawings, the classic way of showing how power is being distributed for a given application. Now, obviously, it begins with the incoming utility service. And in our neck of the woods, lower voltage services below 300 volt basically will start off with the utility meter base located before all other electrical equipment. The reason they do that is to discourage tampering. Who wants to play with a hot meter base? Um, and then it goes in, you have to have overcurrent protection and very often a combination load center to be able to distribute power to what you want to do, et cetera, et cetera, et cetera. In that case, distributing to relatively small loads, although you can get up there a bit. Above that, then it's the other way around. They want to have overcurrent protection, be it fuse or circuit breaker, right off the bat, and then go to your various distribution things. I guess the comment, utility requirements do change, field conditions can be an issue, so utility should be consulted if uncertain. Um, Wherever you are, and as I say, that be the first thing, get hold of utilities. BC Hydro actually had a guide pamphlet, and I'm sure other utilities do. So that's where you would start with. Now, to give you an idea, this is how they're drawn. And if you look at, know how these are drawn, then you can look at it and see what the message is that's trying to come across. Basically, the triangle will be incoming power, and above it, the power supply that is intended from the utility. Um, Start with the beginning, 12240 single, typical household meter base, and then to a combination load. So I call it combination because there is a main breaker for that load center, which also serves as the overcurrent protection for the whole system from there on, along with the individual breakers. Um, so that's directly below the meter base. Now, the next one, 122A three-phase, very similar, um, except the fact that the meter base is different. Instead of a four terminal, see the 4T, it's seven terminal. 347, 600 three phase, a circuit breaker, a meter base, 200 amp, seven terminal meter base, and on to whatever it is you plan on doing past that. And we'll get to that in a second. If you're above, or you're 400 amp and above, basically there aren't meter bases big enough. So what the utility will typically do is have CTs. These are current transformers. In other words, a transformer going around one or more of the leads, and as power flows, it will generate a larger voltage, which the meter can pick up on and know the current flow, amperage. And below that is a potential transformer, which basically is taking the line power and transforming it. And that input will tell the meter arrangement what voltage is actually available at that particular time. And then there's a meter on the meter cabinet itself, and that is what the utility reads. Distribution of that power, once you get past that, in a control panel or whatever, you will have a splitter block, which you can see in the picture on the left, which basically has an input terminals and then a whole bunch of little output terminals. And in a motor control center, as we looked at before, this is sort of a cutaway, you have the horizontal buses bringing in, and the vertical buses that split off that basically are the distribution to the various devices. One thing, if you have an automatic transfer switch and a generator for standby power, and we'll get into that much later, you basically should have the whole service provided from the generator if you don't have utility power. At one time, they used to have the expression emergency loads, which is a complex way of doing it. I think a far better way is to have everything fed, and then if you're worried about overload, if the generator is too small to handle everything, then you can set up your controls to sort of prioritize what is being attached to that load based on its importance and how heavy you're loading the thing. Okay, the emergency power distribution bus, I say I don't like that old approach. Now, here's a typical power distribution drawing, although it's made up more for show than go. showing incoming 600 volt. The main circuit breaker could be fused. Again, you're over current. Your meter base, we're assuming it's 200 amp or below, and it's distributing. And the first one shows us going through a 15 amp breaker to a transformer, which actually should be 600 to 120, 208 three phase, a panel board, and then from the panel board you distribute your various loads, either 120 or 208, single or three phase at 208. With that arrangement, it does not have to be a combination load center, because if you kill that 15 amp breaker, obviously you kill the transformer, and by doing so, the panel board is no longer energized and poses no threat. The next one over is showing for a heater, again, just a 15 amp breaker, feeding onto the heater, which has its own overload and everything else built in. The next one is a fused over current arrangement with the disconnect. The class J breaker. The J breaker is the dual element, or anyway, what's the other expression for dual element? Time delay. And below that we have our starter, and splitting from the starter we're showing where we've got a power factor correction capacitor. And also noting we have class 10 overloads, which we discussed earlier, because they're fairly quick trip. And for most centrifugal pumps, just great. The next one is showing the same thing, but only with a circuit breaker, which I would prefer, as you know, to the disconnect fused switch. Next to that is a solid state starter being fed, and the solid state starter itself has built-in overloads. If you set it up to bypass, then you notice to the left is our bypass contactor, which after the solid state comes up to speed, it takes over. Or if the solid state has failed, you can use it as an emergency way of starting the motor. And to the right of that, the capacitor, as we talked before, that comes on when the motor's up to speed. Beyond that is your typical variable speed drive. And again, the drives themselves have overload capability. So all you need is, if you're at this kind of lower voltage, you really don't have to worry so much about load side protection. Line side, if it's more than 20%, probably at the lower voltage, not such a big deal. Certainly at 600 volt, yes, these line and load side filters. And there's the arrangement with a standby generator, an automatic transfer switch, whereby normally everything's powered off the utility, just the same drawing we had before. In an emergency, if the utility fails, the genset fires up, the genset has a feeder breaker, and that then feeds through the transfer switch, and everything will be powered off that. And that, believe it or not, is the end of that section.